Here's another example to help us look at the least squares regression line and having some understanding of how we rewrite in context and predict different values and talk about residuals. Our problem says, don't you hate it when you open a can of soda and some of the contents spray out of the can? Two statistics students, Carrie and Danielle, wanted to investigate if tapping on a can of soda would reduce the amount of soda expelled after the can has been shaken. For their experiment, they vigorously shook 40 cans of soda and randomly assigned each can to be tapped for 0 seconds, 4 seconds, 8 seconds, or 12 seconds. Then, after opening the can and cleaning up the mess, the students measured the amount of soda left in each can. Here's a scatter plot with the least regressions line. And the least squares regression line for the data below is y hat is equal to 248.6 plus 2.63x. So let's rewrite this equation in context. We need to think about, what does the y represent? Well, the y represents the amount of soda that is left in the can. We could say that this is soda, or the predicted amount of soda, is equal to 248.6 plus 2.63 times the amount of time, or what our x is, which is our tapping time. So we could say that this is the tapping time. In part B, it says to interpret the slope in context. Our slope here is 2.63. So what is that telling us? Well, that tells us for every 1 second increase of tapping, the predicted amount of soda remaining is going to increase by 2.63 milliliters. So for every increase of 1 second in tapping time, the predicted amount of soda remaining increases by 2.63 milliliters. Then we need to interpret the y-intercept in context. Our y-intercept is going to be how much soda is left when no tapping occurs. Our y-intercept in this case is 248.6. So when no tapping occurs, the predicted amount of soda remaining is 248.6 milliliters. For part D, predict the amount of soda that's remaining for a can that has been tapped for 10 seconds. We need to use our equation to predict this. We have our graph, so we could potentially look here at 10 seconds and then find approximately where that would be over here. It looks to be about 275 milliliters or 274 milliliters, around that area. Or we can use our equation. We're going to be more accurate if we use our equation. Let's say our predicted value of soda is going to be 248.6 milliliters plus 2.63 times our tapping time of 10 seconds. When we use our calculator and calculate that all out, we end up with 274.9 milliliters. So it is predicted that if we tap our can for 10 seconds, we will have 274.9 milliliters remaining. And that was approximately, we said 275-ish. That's about what it was. Okay. For E, predict the amount of soda remaining for a can that was tapped for 4 seconds. All we need to do is, again, substitute into our equation. Y hat is equal to 248.6 plus 2.63 times 4. And then use our calculator. And we find out that we are going to predict about 259.12 milliliters of soda. Does that make sense with our graph? We go to 4 seconds. We go to our line. And yes, that looks to be about correct. About 260 milliliters. Part F says to calculate the residual for the soda can that was tapped for 4 seconds and had 260 milliliters of soda remaining. Okay, so we say we have a can that was tapped for 4 seconds and it ended up having 260 milliliters of soda that remained. Our actual value is 260 milliliters. And from the previous problem, our predicted value is 259.12 milliliters. So the residual is going to be our actual value of 260 minus our predicted value of 259.12. So 260 minus 259.12 gives us a residual of 0.88. So this tells us that our predicted value is slightly less than our actual value, or our actual value is more than our predicted value. Part G, what is the actual amount of soda left in a can that was tapped for 6 seconds and had a residual of negative 1.8? We know that y minus y hat is equal to negative 1.8. We're talking about 6 seconds. We want to find the actual value. We can find y hat by using our equation. And in this equation, we find out that our predicted value is 264.38 milliliters. So then we use that in our equation to find our actual. So y minus 264.38 is equal to negative 1.8. I'm going to add 264.38 milliliters to both sides and find out that my actual amount was 262.58 milliliters.